Hello everyone, this is Sanjay from CSIT branch. Today my analog digital electronics Tech Talk topic is power semiconductor devices and components for new power converter developments. In a world with an increasing penetration of wide band gap semiconductor technology, the FIPCON 2015 session on new power devices and high temperature focused on power semiconductor devices and passive components up through integration. For the purpose of refining appropriate power electronic converters by 2025, an important goal was to identify those markets and applications where silicon technology will remain the preferred choice. The semiconductors are rarely the predominant failure mechanism even in silicon modules. The failure mechanisms are usually either the passive components or the packaging. Thus, higher power densities afforded by using WBG semiconductors requires those passive capable of operating at high temperatures and having high reliabilities. Presenters addressed the state of the art and future directions for the magnetic cores, dielectric materials, and electronic packaging integration. Finally, the potential and additional frontiers that merit research in a WBG world, such as new markets, capabilities, circuit architectures, applications were evaluated. WBG technologies, silicon technologies, passive technologies, and power integration technologies. In this slide, it's showing the high power and high speed, where the silicon is mostly used, and the SiC for higher power voltage is more than 1 kilowatt with high current is close to niche market. Gallium nitride on silicon for higher frequency at mid-range voltages is less than 1 kilowatt up to 100 amperes is mass market. And in this graph it is pointed between the output power by operating frequency. Trends in power electron converters, WBG technologies, silicon carbide, SiC and gallium nitride GaN devices are reaching differently levels of maturity with several manufacturers already offering devices in different packages. Example CREC, EPC, GaN system, GENE, SiC, Infineon, On Semiconductor, ROHM, United Silicon Carbide, and Transform. Graphs illustrating output power versus switching frequency and the particular areas where specific devices are more suitable than others are available from different sources are shown in figure. T. Paul Cho from Rensselaer Polytechnic Institute provides a general overview of state-of-the-art semiconductor devices for various applications, state-of-the-art SiC devices, and major breakthrough need for greater penetration in power electronic systems. SiC Schottky barrier diodes are becoming the devices of the choice for systems between 300 and 1200 volts, which require anti-parallel diodes. SiC diffusion and U-shaped metal oxide semiconductor field effect transistors MOSFETs have already reached the market, either in discrete or module packages. They are used in commercial products like solar inverters, and other commercial applications are being explored by several original equipment manufacturers. Lateral high electron mobility transistor GaN devices for power electronic systems under 650 volts have also reached the market and are finding commercial applications in which efficiency and loss switching are design requirements. Panasonic has developed several GaN power integrated circuits having 6 and 9 devices respectively. Current midterm research efforts should produce development related to bidirectional 600 volt GaN MOSFETs and 10 kilovolt SiC bidirectional insulated gate bipolar transistors. GIC and MOSFETs and IGBTs rated about 10 kilowatts and more. GN based power application specific integrated circuits incorporating optoelectronics. And this shows the losses in the magnetic component. Then the core losses are the hysteresis loss and eddy current loss, and the copper loss are skin effect and proximity effect. The main issues that should be addressed are those reliability concerns that hinder greater adaptation of SiC and GaN devices. Reliability and those SiC gate oxide. Material quality for moving to large wafers, which should bring needed cost reductions in addition to potential cost savings at the system level. Power packages capable of removing large heat fluxes from these small area devices based on the gallium arsenide and GaN on native substrates do not seem to be viable at present time, as they require more basic research. And this figure shows the power system in the package. It consists of the two heat sinks and the middle part between the 4 to 8 millimeter. Silicon technologies. Silicon devices continue to be the devices of choice for those applications in which high switching frequencies, high temperature operations, and very high efficiency do not override design requirements. But cost is of the utmost importance. FJ Neodenstan from Infineon delivers a presentation regarding future silicon devices up to the year 2025 and indicated that further optimization of the device's cell should improve performance. Silicon superjunction MOSFETs continues to improve. For example, the specific on resistance is currently at 1 ohms and still far from voltage of 900 volts. Silicon IGBTs are also improving the performance by working on the plasma profile, particularly near the emitters. And new developments on trench-based IGBTs continue to extend the silicon limit while providing cost-effective solutions for high current applications. Reverse conducting IGBTs, integrating the diode function into the IGBT chip and using dynamic gate control to reduce reverse recovery currents are other examples of the necessity of size and thermal impedance reductions along the order of 30 to 50%. R. Bader also from Infineon indicated the power circuit should have symmetry in terms of parasitic inductance, with low parasitic inductance allowing the freewheeling of diodes with large tail currents. This module should experience minimal oscillations when switching the IGBTs. Another research focus in higher operating junction temperatures from IGBTs, currently at 175 degrees Celsius, which is enabled by copper bonding and diffusion assembly of chips with a target temperature of operation at 200 degrees Celsius. Passive component technology. W.G. Hurley from the National University of Ireland Galway made a presentation on the technologies of passives that is co-authored by C.O. Mathuna from the Tyndall National Institute from Ireland. Hurley indicated that the main technical issues when designing magnetic structures are high frequency operation include fringing fluxes around air gaps, minimization of leakage, inductance, packaging, thermal management, and three-dimensional printing. Trends in magnetic design includes printed circuit boards, embedded power magnetics to obtain low profiles, the use of thin film materials integrating inductors and capacitors into single structure, new materials from inductors and capacitors increasing power density and operating temperatures, and integration of passives with sensors. Electronic packaging integration. Heterogeneous integration of passives, WBG semiconductors, integrated circuitry for drive, control, protection and communication, and advanced thermal management devices and methods is a major challenge. Kurt Hone from the Frone Institute posed the question of whether integration is the next milestone of power electronic systems and evaluate the conditions under which integration makes sense. Vendors like Texas Instruments and Vicor from already launched several products integrating semiconductor devices and passives into PCB substrate, leading to concepts like the power system in package and transfer molding technologies. These technologies must ensure manufacturing in terms of material processing, reliability, and thermal management constraints, which limits potential size reductions. High frequency operation using fast switching devices like GA and devices may lead to reduction in the size of the needed capacitors. Silicon devices continue to be the devices of choice for those applications in which high switching frequencies, high temperature operations, and very high efficiency do not override design requirements. Silicon carbide and gallium nitride devices are reaching different levels of maturity, with several manufacturers already offering devices in different packages. High frequency operation using fast switching devices like GAN devices may lead to reduction in the size of the needed capacitors. And these are the references of my given topic. Thank you.